I want to give a quick reminder of how U substitution works for integration. If you're calculating an integral and it looks like a simple function inside of a function, then what you want is the reverse of the chain rule for derivatives, and that's U substitution. You let U equal the function on the inside. So think of this as U to the 10th, and then we have to figure out how to convert dx into du. So to do that, over to the side, I'm going to write out what U is. And then I'm going to take the derivative of U with respect to x. And now, there are some technicalities going on with what I'm about to do that have to do with the definition of differential. But the way that you just do this in practice after you learn the original definition is you think of du and dx as variables themselves. You just treat them like variables. I want to solve for this dx so that I can just plug it in. So I'll multiply both sides by dx. I want to solve for dx, so I'll divide by 4. And now I'm just going to plug that in for the dx. So now my integral is the integral of 1/4 times u to the 10th with respect to u. I'll pull the 1/4 out in front and use the power rule. Whoops. This should be a u to the 11th power plus the arbitrary constant. And then the last step is just to go back and rewrite your solution in terms of the original variable, which was x. U was 4x plus 7. So the steps are: let u be the function on the inside, write the derivative of u with respect to x, solve for dx, plug it in here. A lot of times things will be set up so that stuff will cancel out, and then that will make your antiderivative easier to calculate. Take the antiderivative with respect to u and go back and plug everything in terms of x.